Peace. What's up, y'all? Phil James. So this was given to me by a very awesome subscriber. Very awesome subscriber. Very good article. So thank you for the good work. Here's the title. Qualcomm's 5G antennas are primed for next year's phones. Shouldn't have thought anything differently, of course, but just saying. So we're going to start with the video. It was working, so hopefully it will continue to work. So let's go ahead and try.
It's been a long time coming, but the first ever 5G spec was finally approved late last year. 5G NR, as it's called, will bring about super fast mobile internet by tapping into new spectrum. We're expecting to see the first 5G-ready phones in the first half of 2019, although most people likely won't experience the full benefits of the new technology until about a year later. Still, 5G NR promises to dramatically improve cellular internet speeds and enable experiences like always connected laptops or live streaming from standalone VR headset. The entire mobile industry is excited as hell for it, so here's a little guide to help you make sense of the hype. Let's really briefly go over what 5G is. It refers to the 5th generation of mobile networking standards determined by the 3GPP, the organization that sets the guidelines for every company operating in cellular communications. Get used to hearing the official name, 5G NR, which stands for New Radio, by the way. It doesn't really mean anything, it'll just be used the way LTE is today to differentiate it from previous versions. Where 3G brought the internet everywhere and 4G LTE made it faster, 5G NR is meant to vastly boost the capacity and speed of networks, bringing you your high-res cat videos and 4K VR live streams without any delay. One of the ways 5G will enable this is by tapping into new, unused bands at the top of the radio spectrum. These high bands are known as millimeter waves and have been recently opened up by regulators for licensing. They've largely been untouched by the public since the equipment required to use them effectively has typically been expensive and inaccessible. Like, you'd need a large satellite dish to use these waves to communicate over long distances. But technology has improved to the point where the industry collectively believes we can start tapping them for consumer electronics. And since they haven't been used for much compared to lower bands, they're far less congested and can therefore enable super fast transfers. Qualcomm said you can expect typical speeds of 1.4 gigabits per second. That's 20 times faster than the average US home broadband connection. At peak rates, think 5 Gbps. It's enough to stream 50 4K movies from Netflix at the same time. Millimeter waves tend to be susceptible to interference and generally need to maintain line of sight for transmission to work. At the most basic level, millimeter wave transmissions usually go in a straight line between point A and point B. But with these waves, something as simple as a person walking in between the receiver and the transmitter can block the signal altogether. So, companies have to figure out how to make sure the signal gets from base stations to mobile devices. And with 5G NR, part of the solution are two processes called beamforming and beam tracking. With waves in the lower bands, operators can simply send a bunch of them to your phone since they're strong enough to penetrate obstructions. Think of sending a signal to your phone as trying to light up one person's face in a pitch-black theater. With lower bands, it's like using floodlights. Easy peasy. You can cover larger areas and most likely get the person's face, although maybe not very intensely. With beamforming of millimeter waves, it's more like using a spotlight to find that place, which is tricky if the person is turned away from the source. So you'll have to get creative by using the environment. You can bounce light off reflective surfaces in the theater or set up multiple spotlights in different places to make sure that there's always one that can shine on your desired area. You can also set these lights to sweep, moving around along with the target. Companies like Qualcomm and Ericsson have...
So I wasn't going to pause and do this through this video, but beamforming and beam scattering. Now think about that, because something as simple as you or me walking between somebody using their phone can stop that mobile data transfer, right? So think about that. They have to put it strategically to reflectively beam it off of what? Every single surface in your area, so your phone or your device doesn't lose that data, that mobile data. Now, what's that mean? In the simplest of terms, that means literally the very simplest of terms, you are basically in any major city going to be inside of a microwave in its simplest form, because you will be getting hit from every section by these 5G millimeter waves. Millimeter waves are so easily stopped, as you can tell, by you or me walking between them can stop them. Rain, plants, trees can stop these millimeter waves. Your skin, however, cannot. Your skin will allow these millimeter waves to pierce right through it. By doing so, it damages what? DNA. By damaging DNA, DNA tries to what? Repair itself. Now, when that DNA repairs itself wrong, what's that? A tumor, a cancer, growth. So, I just wanted to make sure everybody realizes that being in a major city is going to be like being inside of a microwave completely.
Equipment that can send and receive these beams. In the most simple scenario for beamforming, where the biggest challenge is that the receiver isn't facing the transmitter, the solution is as simple as bouncing the beam off a surface at a precise angle. The receiving device uses beam tracking to determine which signal is the strongest and picks it up. That sounds straightforward until you consider the challenges when implementing this in the real world. Take an office building, for example. Even when you have base stations set up on your floor, there are many variables to consider. For instance, metals bounce beams, while concrete absorbs them. So if you're inside a conference room, a base station from outside could potentially shoot a beam in through a wall, hit a metal lamp, and bounce off to your phone. To get this to work reliably enough for public use, there have to be a ton of beams for your phone to track. Not only that, your phone's antenna array has to be built in a way that your hand doesn't completely cover up the receiver at any time. Qualcomm's solution is to have antenna arrays in opposite corners of your phone. And since many major smartphone brands have announced that they'll be using...
So now basically, the phones with that little chip right there, that 5G, antenna chip right there, opposite sides of the phone, that means your phone will be an antenna basically everywhere, or it'll go back to that military document where they literally claim they use your skeletal structure as an antenna. So therefore, just by you holding your phone, you can become the antenna that picks up this 5G.
Snapdragon 5G capable components for launches in the first half of 2019, this is likely to be the setup for most of the first 5G ready phones. Not sold? Or not convinced that millimeter waves will be stable enough for sure? Don't panic yet. Just as your phone falls back to 3G when LTE isn't available, 4G will stick around to make sure you remain connected to the internet even if you're not using millimeter waves. Most people won't even have access to 5G immediately. The rollout is likely to begin in cities and spread out to rural areas. And you may need an expensive high-end device to tap the new technology at first. Later versions of 5G will also allow things like IoT devices to connect to millimeter waves, as well as allow for use of unlicensed spectrum to increase speeds some more. But eventually, it should become as prevalent as 4G is today. When that happens, it'll be time to think about 6G. Holy crap, what will that be like?
Well, I can tell you exactly what 6G will be like. They won't waste that name.
Time for a new laptop. Gotta get stuff down as fast as I can think.
Laptops with Windows Ink let you draw right on the screen.
Oh,
With a
damn.
powerful 8th gen Intel Core processor, right?
This kid has done his homework.
Color me impressed.
All right, hold on one second. All right. So, we're going to go ahead and read for 1 second just to get the idea of what I'm getting across. You know, so once again, even if you're not that little chip is supposed to be the antenna.
Porsches are sleek, amazing vehicles. But in a world captivated by SUVs, it wasn't much of a surprise when the German sports car maker introduced a few of its own. But then it unveiled the Panamera sedan.
All right, let's try this again. Qualcomm's 5G antennas are primed for next year's smartphones. Now, that little chip you saw is what will be in the smartphones in order to pick up these 5G millimeter waves. Once again, these millimeter waves are very weak. Rain, plants, wind, anything can affect them. Concrete absorbs, steel and metals reflect. Now, your skin is neither. Your skin is porous. Your skin will absorb these millimeter waves and once again let it cook your DNA. Now, how are they going to get over the antenna issue with cell phones? My best guess is you holding your cell phone in your hand will use your body as a sort of antenna. Okay, that's an absolute fact. Microwaves, your skeletal system has been used for an antenna before. One of the biggest challenges in tapping millimeter waves, MM waves, for 5G is overcoming signal interference because they're easily disrupted by something as simple as someone walking between a transmitter and receiver. MM waves require technological finesse to be harnessed reliably. To that end, Qualcomm today unveiled what it says is the world's first fully integrated 5G NR millimeter wave and sub-6 gigahertz RF module or models for smartphones and other devices. These are the QTM 052 millimeter wave antenna module family and the QPM 56 XX sub 6 gigahertz radio frequency module. Okay, and they'll pair with the company's previously announced Snapdragon X50 5G modem, making next-gen phone networks a reality very soon. Now, if it's in the media, now means it's here now. It's already here. That's clearly the case. By them showing you pictures, they've made it. It's here. People are testing it in the field. They are using it, without a doubt. If you recall, a bunch of major smartphone makers, including Samsung, LG, Sony, HTC, and Xiaomi, already said they'll be working with Qualcomm, and most of them committed to delivering X50 powered phones by the first half of 2019. First half. So that means we could very well see them by December of this year. Those devices will likely use the new antenna and RF modules announced today. Qualcomm told Engadget it had already shipped samples out to its device partners, and it will and will be working with them to figure out the best placement to minimize signal interference due to hand blocking. So how do you get rid of signal interference due to hand blocking? You let that hand turn into the antenna and turn that body into the antenna. So this is going to be much more sinister than anybody ever could possibly imagine. Up to 4 modules can be used in a smartphone. Each of them is barely the size of a fingertip. An integrated 5G NR radio transceiver and other components together with the X50 modem help the antennas seek out the millimeter waves in supported bands. According to the company's statement, a working mobile millimeter wave solution was previously thought unattainable. Now, however, Qualcomm said it is ready for large-scale commercialization, which means we are that much closer to seeing 5G devices in the real world soon. They are here now, people. You saw the chip, you saw the video, they are using it. You see the towers. I know subscribers to this channel that are on the Real Richie from Boston.com, I know you guys have recorded these towers and antennas and posted them on said website. You know, I too just saw a base station in Columbus, Ohio yesterday. There's still a way to go before next year's deadline. In the meantime, carriers are racing to get their 5G networks ready. It won't be too long till we're all live streaming our favorite shows in 4K VR wherever we go, and buffering time becomes a thing of the past. So treasure the mental breaks while you still have them. Treasure it, people. So I will obviously leave you a link in the description just so you can read it. I hate that shit right now. Seriously, making a video every time. Once again, there's your little Qualcomm antenna transmitter receiving device. So, once again, link will be in the description. Hope you guys enjoy. Phil James, and I'm out. Peace.